Cheap SSDs that promise rocket-fast performance often turn into a regretful purchase the moment you start moving real files. You slot them in, watch the green light, and then watch your video editor stall or your AI model load at a crawl. That's why I wanted to see if the WD_Black SN8100 8TB with its built-in heatsink actually feels like a smarter buy instead of another gimmick. Link is in the description if you want to check the product details on Amazon. When I first heard about an 8TB PCIe 5.0 drive, my first thought was, do I really need that much space on a single M.2? Most of us have been burned by buying a high-capacity SSD that sits idle because the rest of the system can't keep up, or by picking a drive that overheats in a cramped case and throttles right after a few minutes of work. The SN8100 tries to solve both issues by marrying a massive 8TB capacity with a custom low-profile heatsink that WD says is the lowest profile opt-for PCIe 5.0 cards. In practice, that means you can actually mount it in a mid-tower that only has a thin M.2 slot and still expect the drive to stay cool during those marathon editing sessions. Let's talk about who actually benefits from a drive like this. If you're a video professional who routinely works with 8K footage, an 8TB SSD can hold an entire project raw files, proxies, renders without you having to juggle external drives. When you're training a machine learning model on a local workstation, the model weights and datasets can easily exceed a terabyte, and having that data sit on a drive that can read at close to 15 GB per second cuts epoch times noticeably. Gamers who keep a massive library of AAA titles, plus a growing collection of mods and texture packs, also feel the impact. Load screens that used to take 10 seconds drop to 3 or 4. In short, the SN8100 shines for power users who need both space and speed in one package. On the flip side, if you're building a mainstream gaming rig or a budget workstation, you'll probably find the SN8100 overkill. A 2TB or even 4TB PCIe 4.0 drive already gives you enough headroom for most games and a comfortable editing buffer, and it comes at a fraction of the price. Moreover, the SN8100's advertised 14,900 MB per second sequential read and 11,000 MB per second write only happen when you're plugged into a motherboard that offers a full PCIe 5.0 x4 lane. Older Intel Z690 or AMD X670 boards can still run the drive, but they'll cap the performance at PCIe 4.0 speeds, which means you're paying a premium without reaping the headline numbers. If your system can't supply the required bandwidth, the value proposition shrinks dramatically. Now, let's look at the practical strengths that matter after you've actually installed the thing. First, the capacity. 8TB is a rare sweet spot for an M.2 drive. Most high-capacity SSDs top out at 4TB. That alone reduces the clutter of external enclosures, and for people who travel with a single laptop, it's a game changer. Second, the heatsink design. Unlike many high-performance drives that ship with bulky, fan-cooled solutions, WD's low-profile heatsink slides under most standard M.2 slots without touching other components. In my testing, even after moving a 300 GB 4K video file repeatedly, the drive's temperature stayed below 70 C, which is well under the throttling threshold. That stability translates to consistent performance when you're rendering a timeline or running a training loop that lasts for hours. The weaknesses are more about context than the hardware itself. The price tag is steep. An 8TB PCIe 5.0 SSD sits in the high four-figure range, and you're essentially paying a premium for both the capacity and the next-gen interface. If you're on a tight budget, that money might be better allocated toward a faster CPU or more RAM, especially for AI workloads where memory bandwidth can be a bottleneck. Another practical concern is power draw. The SN8100 pulls more watts than a typical PCIe 4.0 SSD, which isn't a problem for a full tower with a decent PSU, but it can be a limiting factor in compact builds or laptops that support PCIe 5.0. You'll want to verify that your power delivery to the M.2 slot meets the spec, otherwise you could see occasional power-related hiccups. A subtle trade-off that shows up in everyday use is the lack of a DRAM cache on many high-capacity PCIe 5.0 drives. While WD doesn't explicitly call out a DRAMless design, the size of the NAND and the focus on raw bandwidth suggest that the drive